Last time, we put sine and cosine on a circle. One angle in, two coordinates out. Now we add two of those angles together. And this is the page that falls out, the one everybody dreads. 24 trigonometric identities. Sum formulas, difference formulas, double angle, half angle, and whatever these last 8 are supposed to be. Most people meet this page and start memorizing. You do not have to, because all 24 of them are hiding inside one rectangle. Let me draw it for you. Here is the plan. We build one diagram and read two formulas straight off it. Then we do just two things to those two formulas. Flip a sign and set the two angles equal. That is it. Two moves, applied over and over, and the other 22 identities fall out on their own. Nothing to memorize, because there will be almost nothing left to memorize. So, the diagram. Start with a rectangle. Bottom left corner, call it O. From O, draw a line up at some angle. Call that angle alpha. Let it run until it meets the right-hand edge, and mark that point P. Now, at P, turn 90 degrees. Exactly a right angle. Head off that way to the top edge, and mark Q. Now join O, straight to Q. Look at the angle it makes with the bottom edge. It contains alpha, and then a little more. Call the little more beta. So the line from O to Q sits at alpha plus beta. One step here is doing all the work, so let us be sure of it. Draw a horizontal left from P, and a vertical down from Q. That makes a small triangle at the top, and I claim its angle at Q is also alpha. That horizontal is parallel to the bottom edge, and the line from O cuts across both. Parallel lines, cut by the same line, make equal alternate angles. So the angle underneath at P is alpha 2. But the whole angle at P is a right angle. Take alpha away, and 90 minus alpha remains, which forces the last angle, at Q, to be alpha. And look, that little triangle has both alpha and 90 minus alpha inside it. So one side answers to both of them, which is all that sine of 90 minus alpha equals cosine alpha ever meant. Now read the first formula off the picture. Set O to Q to have length 1. Then sine of alpha plus beta is just the height of Q. And the picture has already cut that height in two. The lower piece is the height of P. The upper piece is the short vertical on top. Now, O to P has length cosine beta, because in that right triangle the angle at O is beta, and the hypotenuse is 1. So the height of P is cosine beta times sine alpha. And P to Q has length sine beta. So the upper piece is sine beta times cosine alpha. Add them. Sine of alpha plus beta equals sine alpha cosine beta plus cosine alpha sine beta. The vertical side adds. And the second formula is already sitting there too. Cosine of alpha plus beta is the horizontal distance out to Q. So look along the bottom. Going out to underneath P takes you cosine beta times cosine alpha. But Q is not above that spot. It sits back to the left by exactly that horizontal line, which is sine beta times sine alpha. So this time, we subtract. Cosine of alpha plus beta equals cosine alpha cosine beta minus sine alpha sine beta. That minus sign, the one everybody gets wrong, is just a step backwards in the picture. Now let us make those angles concrete. Let alpha be the angle in a 3, 4, 5 triangle. And let beta be the angle in a 5, 12, 13. Then scale the diagram so O to Q has length 65. And watch. Every length in the picture turns into a whole number. 60, 25, 48, and a step back of 15. 36, then 20 more. 36 plus 20 is 56. 48 minus 15 is 33. So sine of alpha plus beta is 56 over 65. And the cosine is 33 over 65. And look, 33, 56, 65 is a right triangle in its own right. 2 went in. A third came out. Here's what that buys you. Sine of 75 degrees. Your calculator will hand you a decimal, but now you can get it exactly. 75 is 45 plus 30. And you already know both of those. So it is sine 45, cosine 30, plus cosine 45, sine 30. Pause here and finish it, if you like. You should get root 6 plus root 2, all over 4. An angle that is not on any special triangle, made exact. Move number 1. And there is nothing new to draw. In both formulas, replace beta with minus beta. We already proved what that does. It is the first of the 3 mirrors from last time. Turning backwards reflects the point in the x-axis, so it keeps its distance across, and flips its height. So cosine of minus beta is just cosine beta, unchanged. And sine of minus beta is minus sine beta. Substitute those in. In the sine formula, the plus becomes a minus. In the cosine formula, the minus becomes a plus. 2 more identities, and we did not draw a thing. 2 more, almost as cheap. Tangent is sine over cosine, which last time was just the slope of the radius. So take the sine formula, and divide it by the cosine formula. Now divide the top and the bottom of that by cosine alpha cosine beta. Every term collapses into a tangent. Tangent of alpha plus beta equals tangent alpha plus tangent beta, over 1 minus tangent alpha tangent beta. Flip the signs, as before, for the difference. That is 6 identities. And we have still only drawn one picture. Now do both moves at once. Take the cosine formula, and set beta equal to minus alpha. On the left, cosine of alpha plus minus alpha. The angles cancel, so that is cosine of 0, which is 1. On the right, the cosine is unchanged, so the first term is cosine squared alpha. The sign flips, and subtracting a negative makes it positive, so the second is plus sine squared alpha. Read the line back. 1 equals cosine squared alpha plus sine squared alpha. That is the first identity anybody has ever taught. And it was a special case of this one all along. Divide through by cosine squared, and 1 plus tangent squared equals secant squared falls out as well. Move number 2, on its own this time. Set beta equal to alpha, no sign flip. Then alpha plus beta is simply 2 alpha. In the sine formula, both terms become sine alpha cosine alpha. The same thing twice. So sine of 2 alpha is 2 sine alpha cosine alpha. In the cosine formula we get cosine squared alpha, minus sine squared alpha. And now that we have Pythagoras, we can trade either square for the other. 2 more versions of the same identity. Divide, as always, for tangent of 2 alpha. 5 identities from 1 substitution. And with our numbers, doubling the 3, 4, 5 angle gives 7, 24, 25. Another right triangle. Now run that backwards. One of those versions said, cosine of 2 alpha equals 1 minus 2 sine squared alpha. Do not read it as a recipe for doubling an angle. Read it as a recipe for having one. Rearrange for the sine, and you get sine of theta over 2 equals the square root of 1 minus cosine theta over 2. Do the same to the other version for cosine of theta over 2. Divide them for the tangent. And check it. Our cosine was 7/25, and the formula hands back 3/5. Exactly the angle we started with. 8 left. And one last trick gets all of them. This time, do not substitute anything. Just add 2 of our formulas together. Sine of alpha plus beta, plus sine of alpha minus beta. The second terms have opposite signs, so they cancel, leaving twice sine alpha cosine beta. Now rename. Let the 2 angles on the left be x and y. Then alpha is their half sum, and beta is their half difference. Read it again in that language. Sine x plus sine y is twice the sine of the half sum, times the cosine of the half difference. Subtract instead of adding, do the same to the 2 cosine formulas, and there are all 4 sum to product identities. Read those 4 backwards, right to left, and they become the 4 product to sum identities. 24. So here is that dreaded page again. And this time, with the arrows drawn in. 2 formulas came out of the rectangle. Flipping a sign gave 2 more. Dividing gave the 2 tangents. Setting beta to minus alpha gave Pythagoras, and its secant version. Setting beta to alpha gave the 5 double angle formulas. Reading those backwards gave the 3 half angles. And adding and subtracting gave the last 8. 24 identities. One of them is a picture. Everything else is bookkeeping. So what should you actually remember? Honestly, the rectangle. If you can draw that, and you remember that the vertical side adds while the horizontal side subtracts, you can rebuild any of the 24 in about a minute. That is not a memory trick. That is just knowing where they came from. Two pictures, then. A circle, for what sine and cosine are. A rectangle, for what happens when you add two of them. The first one is linked below, if you have not seen it. And if you like this, one idea taken apart until there is nothing left to memorize, then subscribe.